Hi all. In this video, we are going to explore the interfacing of PIC18 microcontroller. In that, we are choosing interfacing LCD with Hi. In this video, we are going to explore the interfacing of PIC18 microcontroller. In this, we are see about the interfacing of LCD. Interfacing of 16:2 LCD with PIC microcontroller. So explore 4-bit mode for efficient data transfer with PIC microcontrollers, and we are seeing the practical applications of character LCDs and hands-on approach to interfacing. So in empathize part, LCDs in our daily lives. We know that ATMs, calculators, medical devices and industrial control panels. If we consider a ATM, the transaction details balance display or for example 20:4 LCD displays are often custom used. Calculators, numeric results for example FX9991EX with 192:63. So it gives a dot matrix or simple calculation that is 16:2. Medical devices, it used for patient vital signs that is blood pressure monitoring. Industrial control panel, machine status, error code, for example PLC interfacing will be displayed. Understanding the 16:2 LCD module, it gives a display capacity and standard display shows 16 character across 2 lines, and here they using HD 44780 controller, and it is an industry standard chip is embedded within the module, and it is a 4-bit versus 8-bit mode, and 4-bit uses fewer PIC or input output pins, that is a D4 to D7, and current draw is available, and typically 1 to 2 milliamps without backlight and 120 milliamps with backlight are used. Essential LCD control pins explained. In that the main pins are RS, it is nothing but register select. Always it is a high for data and low value for command 1. The next one is the RW. The RW is nothing but read or write signal. So the signal is high means it will read the input, and if the signal is low means it is a low for writing option, typically the grounded for write only. Next one, the E pin, it is nothing but the enable pin. It always high to low pulse to latch or data command. Data pins 4 to 7, that is a transmit 4-bit nipples into the microcontroller. Core LCD command setup for 4-bit mode. First we have to set the initialization sequence, that is 0:02 return home, then 0:28, that is a 4-bit 2 lines, and 5:8 front end mode. Display on or off, cursor blink. So 0:0C display on and cursor off, it is a blinking off condition. Clear display, so 0:01 clear screen sets DRAM addresses to 0:00. Set D square RAM address, it is a 0:80 for line 1, exact 0:XCO for line 2. PIC microcontroller setup for LCD. The command PIC models are PIC16F877A and PIC18F4550 are suitable choices for common PIC models. The next one is input-output port configuration. Designate the specific port pins for RS, RW, E, D4, D7 connections. The crystal oscillator, typically 20 MHz, provides a stable timing for operation. Development tools, use MPLAB ID into XC8 compiler for standard development. The ideate phase, designing a scrolling text animation. The first one is a concept. So display PIC18 microcontroller power scrolling. Next one is a shift characters left right by rewriting the display. And then timing, The use precise delays, example 200 milliseconds for smooth animation. And D-square RAM addressing, it is manipulate addresses to create the scroll effect. Based on this, we have developed a prototype that is displaying sensor data. The first scenario is show the temperature 25.5 degrees Celsius and humidity 60% on LCD. So data conversion based on the convert numeric values, that means float into internal values, to ASCII strings. String handling, use printf or custom routines for formatting. Cursor positioning, use LCD control function for before writing. Test and debug, it is a fixing garbage characters. The first one is the common cause 1, incorrect LCD initialization sequence or timing delays. Common cause 2, wrong pin connections, that is a D4 to D7 swapped. Common cause 3, it is a power supply issue, that is example unstable 5 volt or low current values. Debugging tip, check e-pulse width and data line stability with oscilloscope. The conclusion for next steps, it is advanced projects implement custom characters and graphical LCDs, and future enhancements are interfacing real sensors, keypads and menu systems. Mastered skills, LCD initialization, custom text display, basic debugging, and the key takeaways are 4-bit model efficiency, command structure and common pitfalls. Thank you.